Continuing with the secure design principles, other principles that should be noted include techniques for ensuring the confidentiality, integrity and availability, security controls, and trust and assurance. To ensure the security of data, all the components that have access to the data should be made secure, meaning that they should do what they are supposed to do only. There are several scenarios where the confidentiality, integrity and availability of data could be compromised, such as if an application has been compromised, if multiple users change the same data simultaneously, or if data modification results in data loss. To counter these incidents, the following principles were established. The first principle is confinement, where an application is restricted to perform specific actions to specific data or resources, and any irregular actions beyond the granted authority would be denied. The second principle is bounds, where each process on a system is assigned an authorization level, which sets the limits to what the process can do. The third principle is isolation, where the effects of the actions of any process are isolated to the limits that it has been set to. Another main security principle is controls, which is based on using access rules to limit the access of resources by users or processes. Simply put, a control would specify which subject is allowed to access which object. For example, a read-only access right given to a user allows him to have access to specific files, but he won't be able to modify or delete them. There are two types of access controls, which are mandatory and discretionary. Mandatory controls specify subject and object attributes, where if a user wants to access a specific object, there has to be a rule that matches his clearance level and allows him to access the required object. On the other hand, discretionary controls allow for more flexibility, where a user has some sort of authority to choose which objects he needs to access, however this authority is limited. The last security principle to be discussed is the trust and assurance. To ensure that a system is secured, security should be integrated into the design, and it should be engineered, tested, evaluated, and accredited. Systems are considered to be trusted when all their security mechanisms and controls are functional, and a stable environment has been ensured to protect sensitive data. Assurance is the level of confidence that a system is secure as per the expectations. It is a continuous process of constantly evaluating and verifying that a system's security is still intact, especially when new changes that affect the system have been implemented. The level of required assurance depends on the criticality of the system, or on the sensitivity of the data that it processes.